Thank you very much. Can you hear me okay?
Loud and clear.
Yeah, perfect. Thanks very much, and Anna and everyone in EPIC for organizing this. So it's great to see some faces again. As Josue said, it's what's important I want to talk about today is not what we do in this, this packaging services in PIXAPP, because really we're not there to, we're there to support industry. But really what I want to talk about is the move towards standardization and looking at lower cost packaging. And how we're working both in Europe and globally to achieve that. So you've probably seen this before. The kind of packaging capabilities we originally developed in PIXAPP, and we're continuously adding to those. So a whole range of optical, electrical, thermal, mechanical, and they're working very well. And we're engaging with now, about 150 companies across the world. From multinationals to startups, SMEs, and a whole range of applications. And as Josue said, we have to be very careful that we're not, customizing, reinventing the wheel, and making sure that we really kind of like develop standards in that way. So I think this view graph really captures that. And essentially what you have on the left-hand side is what we call the Foundry PDK. So this is the process design kit. So typically, that would include things like modulators and different types of waveguides and different functionality on the actual photonic chip. And there's building blocks, there's a library, and for example, OptoDesigner with Synopsys make that available. So it's relatively straightforward process to be able to lay out a photonic device, go to a foundry, and that's validated. That PDK is validated. So what we've been trying to do in PIXAPP, besides developing up the packaging capabilities and offering those capabilities to people, industry, is really to kind of try and put a standard process around that. So over the last number of years, what we've been doing is developing what we call an ADK, and that's an assembly design kit. So in that ADK, we've got a whole range, and it goes back to that previous view graph I showed: fiber attach, micro optics, flip chip of electronics, different types of electrical packaging, ribbon. I also mentioned flip chip, but different types of wire bonds, laser integration, and we're continuously adding to those. And basically it complements the PDK. And when you bring those together, and again, we've been working with Synopsys because they're part of our pilot line, formalizing that into a standard offering. So again, it's a software-driven ADK, much like the PDK. So designers can pull from the library and build out their package. So ensure that the chip is laid out, that it can be packaged. And we don't want that just to be from a PIXAPP perspective. We want to make sure that the companies across Europe and across the world and other foundries like AIM Photonics, and I'll give you an example of how we're working with AIM, we take a similar approach. And that'll enable people then for different applications to lay out the chip that it's suitable for packaging. So this is just one example. This is one of our demonstrators. We have a number of demonstrators to show how all this can be done. So this is basically the PDK. So you lay out your chip, but it's laid out in such a way the ADK interfaces with that. So as I say, this is a capability we've developed up in PIXAPP, where we got the different types of electrical, ribbon, standard wire bonding, flip chip. These are drivers for the modulators on the silicon photonic chip. You can see this hybridly integrated laser, micro optics, and then the amplifier, the receiver. And again, this is a demonstrator to show how all of that works. And what's really important is that the chips are laid out for packaging. So we've worked with foundries in Europe. We have these what we call reference chips. So they're following these design rules. And basically, if you follow these design rules, this ADK that's in the Synopsys software, the chips can be packaged. And as I say, we want to ensure that it's not just PIXAPP. Other packaging providers, they can avail of this type of layout situation. So this is a very nice example. So when the chips are laid out in a formalized way and they follow the respected design rules, here you can see, for example, Tech are using these chips to validate equipment installs, because these are standardized layouts. So the customer who buys this machine does not have to use their own product, because you're assuming that the product will be following these ADKs. So then, therefore, you can use this kind of agnostic or generic reference chip to validate the machine. So that's just one example of how these reference PICs not just are useful for validating packaging processes, but also equipment and other materials like fiber arrays, micro-optics, etc., etc. So this principle of this type of generic reference PIC has proved very, very interesting, and we're starting to work with other foundries around the world. So this is a very nice example. Over the last year, we've worked with AIM Photonics, the foundry in the US, Stefan Prebel, Tom Brown, and David Harme in AIM. And again, they've kind of copied our approach. So as you can see in this particular chip, it's basically like a Swiss Army knife, if you want to call it, a whole array of optical and electrical IOs, edge couplers, grating couplers, bonds for flip chip, wire bonding, RF lines, photodiode heaters. And we're currently working on investigating how we can integrate lasers into this. So 2.5D type integration. And again, it's a standardized design following the ADK rules. So finally, I want to mention a new, very exciting project we're working on called Photonic Leap. And it's kind of following that kind of ADK approach. We're bringing in new technologies, and this is driven around surface mount and using micro optics. So we're developing processes for integrating micro lenses onto PICs, and again, taking that surface mount. So really reducing the cost of packaging by about an order of magnitude, if not more. So that enables us then to do things like multi-project wafer runs, because it's, as Josue said, it's wafer level packaging, and we can standardize the layout. So our ultimate objective is to move towards ADKs and design rules. And then we can scale up from multi-project runs to large-scale wafer runs. And also the layout is compatible with wafer level testing, both optical and electrical. This is a type of ball grid array. So again, standardization, we're trying to drive that towards standardization.